Web scraping is an incredible process that simplifies the task of extracting large volumes of data from websites swiftly and effectively, a task that would be extremely time-consuming if done by hand. BeautifulSoup is a Python library that provides tools for scraping information from web pages. It makes the extraction of data from HTML and XML documents straightforward and efficient. You can collect information from web pages for market research, competitive analysis, academic research, and machine learning projects. Let's explore some common use cases for BeautifulSoup with Python. The first is data extraction. BeautifulSoup is perfect for extracting specific data elements from a web page. Whether it's prices, product details, or news headlines, you can target and extract the information you need. The second is website parsing. It enables you to parse the structure of a website, making it easier to navigate through the HTML or XML elements. This is especially useful when dealing with complex page structures. The third is automated testing. BeautifulSoup is also valuable for web scraping and automated testing. You can use it to validate that specific elements exist on a web page or to check if the layout remains consistent. The fourth is monitoring competitor prices. For businesses, BeautifulSoup can be employed to scrape and monitor competitor prices, helping you stay competitive in the market. With BeautifulSoup, the world of web data is at your fingertips. You unlock the potential to extract and transform web data, keeping you ahead in the ever-evolving digital landscape. Whether you're a developer, a researcher, or a business strategist, with BeautifulSoup, you're well-equipped to explore the digital realm. Ever wondered how the web weaves its magic, turning a jumble of code into the dynamic pages you navigate daily? In this lesson, you'll review some of the basics of HTML and unravel the intricacies of the web. HTML stands for Hypertext Markup Language and works by categorizing different elements of an HTML document with specific tags. Every HTML document starts with a document type declaration at the top. !doc_type HTML. This helps browsers display web pages correctly. Next, the content of the HTML document begins with the HTML tag and ends with the /HTML tag. Then there's the head of the HTML document, which begins with the head tag and ends with the /head tag. This part is not displayed in the browser when the page is loaded. It contains metadata such as the page title, links to CSS if you choose to style your HTML content with CSS, links to custom favicons, the author, and important keywords. The body of the HTML document begins with the body tag and ends with the /body tag. Inside the body, you can have headings and paragraphs. Headings are defined by the H1 through H6 tags. An H1 heading will be displayed by the browser in a larger font than an H2 heading, and so on. A paragraph begins with the P tag and ends with the /P tag. Now, there are lots of other HTML tags as well, but these are the building blocks. Understanding HTML structure is a foundational skill for anyone using Python for web automation. Whether you're scraping data, testing web applications, or interacting with dynamic web content, a strong grasp of HTML enables you to navigate through websites effectively and automate various tasks with precision. After you've inspected your data source, the next step is to create a request to the website that you want to scrape data from, and then parse the response you get back. In this lesson, you'll discover how to write code to successfully create a request and parse HTML code. Your first goal is to create a request to get HTML code from this web page, which contains a public catalog of books that are in English and categorized as humorous. Copy this URL and then open up request and parse startercode.py in VS Code. At the top, the libraries you'll need have been imported: requests and BeautifulSoup. Paste in the URL and store it in a variable as a string. Call request.get, pass in the URL, and the header's argument equal to a dictionary that maps accept to text/HTML. This ensures that you will only get HTML in the response. Save the result in a variable called response. Your second goal is to parse the HTML response. So call BeautifulSoup and pass in response.text followed by html.parser. This second argument tells BeautifulSoup to use Python's built-in HTML parser. Save the result in a variable named parsed response. Finally, call parsed response.prettify to format the parsed HTML response in a way that's easier to read, and print it out. Now save the program and run it. As you can see, the program successfully got HTML code from the web page. Go ahead and practice with a web page of your own. Make a request to get HTML content from the web page using the request library, and then parse it using the BeautifulSoup library. Now it's time to pull back the curtain and see what makes up the websites you're interested in collecting data from. Before diving in to gather data from a web page, you'll need to meticulously review its HTML structure and identify the elements you want to extract, as a foundation for your future analysis and automation. In this lesson, you'll gain the expertise to examine a page, pinpoint the data treasures you seek, and set the stage for successful scraping adventures. Let's dive in. Here I have the following web page open. This contains a public catalog of books that are in English and categorized as humorous. And I'll use the browser's Inspect tool to explore its HTML structure. Right-click while on the web page and then click Inspect. You'll see the structure of the HTML document pop open on the right. Now try to locate the data corresponding to the first book within the HTML code. Start by clicking on the section tag where class equals browse content. Next, click on the div tag where class equals browse items grid. Then click on the first div tag where class equals browse item. Afterwards, click on the first div tag where class equals b-item grid. When you hover over b-item grid in the HTML code, you'll notice that the first book is highlighted in the web page. Nested inside of this, there's b-item cover, which represents the book cover and contains the image, block item title, which represents the book's title, block item author, which represents the book's author, and block item price, which represents the book's price. These are all types of data that you could potentially scrape from this data source. Now that you've uncovered how to inspect a data source, go ahead and try using the Inspect tool in your browser to examine the HTML structure of a different web page. After you receive a response to your request for HTML code, the next step is to extract the specific pieces of data that you need. This is where the real magic of web scraping happens. In this lesson, you'll discover how to extract data from HTML code using BeautifulSoup in Python. This web page contains a public catalog of books that are in English and categorized as humorous. Assume that you've already created a request to get HTML code from this web page and parse the response. So your next goal is to extract data from the parsed HTML response. Specifically, you'd like to find all the book titles that appear on this web page and print them out. Use your browser's Inspect tool to inspect the first book that appears on this page. In the HTML code that pops up on the right, hover over the element that corresponds to the title of the first book that appears on this page. This HTML element has the tag A and the class block item title. Inspect the next book. The HTML element for this book's title also has the tag A and the class block item title. So this tag and class can be used to extract elements for book titles on this web page. Now open up Extract Data from HTML startercode.py in VS Code. The requests and BeautifulSoup libraries have been imported. The URL of the web page to scrape from has been defined. A request has been sent to get HTML code from the URL, the response saved in a variable named response. The text from the response has been parsed and saved in a variable named parsed response. To identify all the book titles, call parse response.findAll and pass in the string A followed by class underscore equals block underscore underscore item dash title. The A is passed in as the first argument because the HTML elements for book titles all have the HTML tag A. And the second argument is passed in because the HTML elements for book titles all have the HTML class block item title. Finally, use a for loop to iterate over the book titles and print the text for each. Now save your program and run it. There you go. The program successfully scraped all the book titles that appear on that web page. Go ahead and practice extracting data from HTML code that you've scraped from other websites using BeautifulSoup in Python. All right, data enthusiasts, it's time to challenge yourself to create a scraper that efficiently navigates and extracts information from multiple pages. Many websites are structured with pages that divide information, and you might need to scrape more than one page to get the data you want. In this lesson, you'll examine a website with opportunities for multi-page web scraping and plan a technical workflow for scraping data from multiple pages. This contains the first page of results when browsing for best-selling books in English from this public catalog. It shows the first 50 books out of 3,477 total. Now replace the page equals 1 with page equals 2 in the URL. You can now view the second page of the results. The URL structure is consistent, so if you wanted to scrape multiple pages, here's how you would approach that. Create a for loop to iterate over a range of the page numbers that you want to scrape from. Inside the for loop, define the URL to be the first part of this URL, which is everything until page equals, and then add the page number at the end to specify which page to scrape from for this iteration. Using the requests library, send a request to get HTML code from the complete URL. Using the BeautifulSoup library, parse the response. Extract all the elements that you want from that page. Print out the page number, print out the data that was found for this page number, and as an optional final step, call the sleep function from the time library to space out each iteration of the loop. Now that you explored a website with opportunities for multi-page scraping, you're ready to dive into the implementation in Python. Picture this, a treasure trove of information neatly organized but spread across various pages. How do you gather it all without tedious manual effort? That's where Python automation prowess comes into play. In this lesson, you'll implement a multi-page web scraper using the requests and BeautifulSoup libraries. Navigate to this web page. This contains the second page of results when browsing for best-selling books in English from this public catalog. Your goal is to build a web scraper that collects all the book titles and authors displayed from the first, second, and third pages of this website. Go ahead and copy the base URL, which is everything in this URL until page equals. Start by using your browser's Inspect tool to inspect a couple of books on this web page. For the first book, the HTML element for the title has the tag A and the class block item title. And the HTML element for the author has the tag A and the class block item author. Similarly, for the second book, the HTML element for the title has the tag A and the class block item title. And the HTML element for the author has the tag A and the class block item author. Now open up Scrape Multiple Pages startercode.py in VS Code. The program starts with the necessary import statements. Then there's a for loop that iterates over the range 1, 4. A reminder that Python's range function includes the first argument and excludes the second argument. So page numbers 1, 2, and 3 will be included. Inside the for loop, paste in the first part of the URL you had copied previously from the website as a string. This is then concatenated using the addition operator with page number converted to a string. Then request.get is called, the complete URL is passed in, and the header's argument is set equal to a dictionary that maps accept to text/HTML. This ensures that you will only get HTML in the response. Next, BeautifulSoup is called. Response.text is passed in, followed by html.parser. This tells BeautifulSoup to use Python's built-in HTML parser. Then, parseResponse.findAll is called. The string A is passed in, followed by class_block__item-title. This will help you extract all the elements specific to book titles from that page. Afterwards, parseResponse.findAll is called. The string A is passed in, followed by class_equals block__item-author. This will help you extract all the elements specific to book authors from that page. The page number is printed out. I wrote a Lambda function that formats the text of each book title to make it easier to read, which I've mapped to the title elements, and then printed out the resulting list of book titles for that page. I applied similar formatting to print out the book authors for that page afterwards. Lastly, I called the sleep function to pause the program for 1 second between iterations of the loop. Now save the program and run it. As you can see from the output, the list of book titles and the list of book authors have been printed out for page 1, then page 2, and finally, page 3. Think about a website that you'd want to scrape multiple pages of data from and try out the technique from this lesson.